So in this video, we're going to go over getting the original function back from the derivative. Okay, so in other words, you're going to be given the derivative and you want to know the function. But in this particular video, you're just going to be given a table for the derivative. All right, so how are we going to get the function back? Just by knowing the derivative from a table. And remember, we're going to need this fact, the fundamental theorem of calculus. And the fundamental theorem of calculus states that if you want to know the function, okay, right here on the right hand side, so that's the original function, then what you can do is integrate the derivative. In particular, if you integrate the derivative over an interval, let's say from a to b, then what you get is the total change in the original function f. All right, and by total change, it just means the value of the function at the right endpoint minus the value of the function at the left endpoint. So how much has it changed over that interval? All right, so let's consider this example. You have this chart of Q and MC. So of course MC is the marginal cost. So this here is the marginal cost. All right. And the question is, how much will it cost to produce 300 items, Q being the number of items, of course. So how much does it cost to produce 300 items if you're given that the fixed cost is $500? So what are you going to do? We're going to use the fundamental theorem of calculus, and that says that when you integrate from 0 up to 300, what you're going to get, so of the marginal cost, what you're going to get is the original function evaluated at 300 minus the original function evaluated at 0. All right? So remember, the original function is just the cost function. And remember, the marginal cost is just the derivative of the cost. So that's why we can use the fundamental theorem of calculus. And now how does that fixed cost come into play? Well, that's just how much it costs you to produce 0 items, because the fixed cost is how much money you need to spend to even start producing those items. Okay, so basically if you want to find the total cost, which is right here, all you need to do is find the integral. So that's one step, and then the second step is adding 500. So all we do basically is put this over to the other side. Okay, so our goal is to find the total cost, and in order to do that, we're going to have to find the integral and then add $500 to it. All right, so let's go ahead and do that. So if you have a chart, one good thing to do so that to help prevent you from messing up is to just plot out all the points in a graph. So I've done that for you here. And since we're going to be finding the area, look at this. I'm just going to draw these lines that connect all these dots. Okay, so remember, we want to find the integral from 0 to 300 of that graph, so the marginal cost. And remember that because this function is positive, computing the integral is the same thing as computing the area under the graph, the area between the x-axis and the graph of the function. So let's just write that out. It's just going to be the area between x-axis, or q-axis I should say, q-axis and graph of the marginal cost. Okay, so let's go ahead and do that. So to find this integral, we're going to just find the area. So let's draw these lines down. Those will be the lengths of the heights of the rectangles. Now look what I'll do here. I'll make this line and this line and this line. And so now we have triangles and rectangles. So let's compute the area of the rectangles, because that's pretty easy. So this first rectangle right here has length 100 and height 20, so the area is 2000. The next rectangle has length 100 and height 18, so that's going to be 1800. And the same thing with the last rectangle. So now let's compute the areas of the triangles. This first triangle right up here, well, it has a height of 5 and it has a length of 100. So the total area will be 5 times 100, but then divided by 2. So that's 250. The next triangle has height of 2 because the distance between 20 and 18 is 2. So it has height 2, but length 100. So 100 times 2 is 200, but divided by 2 is 100. And finally, the last triangle has height of 4 and length of 100. So the area is 200. All right, so let's go ahead and add up all those numbers. So let's do the rectangles first. We have 200 plus 2 times 1800. Okay, and then the triangles, that's 250 plus 100 plus 200. So when we add all these numbers up, we have 2000 plus 1800 times 2, that's 5600. And then we add the areas of the rectangles, which comes out to be 250 plus 100 plus 200, which is 550. And so you add all of that up and you get 0 here, 5 here, 11 here, and a 6 here. So $6,150. That's what the integral comes out to be. And so the final answer is what? The final answer is the following. Put it here in this little corner. So the final answer. So remember, we wanted the total cost. So the total cost, I'll put that as TC. It's going to be equal to the integral, which is $6,150, but then plus the fixed cost, which was 500. And so the answer comes out, the grand total comes out to be $6,650. All right, and there you go. Now, one thing I just want to point out, that integral that we actually computed, that's what's called the variable cost. So this thing right here, this is called the variable cost. And so basically, the total cost is just the variable plus the fixed cost. Okay, so let's just write that out. So just for future reference, the total cost is equal to the variable cost plus the fixed cost. That variable cost was the integral. And the fixed cost is just the value of the cost function when you've produced 0 items. All right? And that is all.